question that we have is the product of the array except self. So let's see what we have to do with this one. So we're given an array, integer array nums. Return an answer such that the answer I is equal to the product of all the elements of the nums except num. Right. Okay, the product of any prefix or suffix nums is guaranteed to fit in 32-bit integer. You must write an that uses. Okay, without using the division operation. Without using the division operation. I mean, if you can't use the division, then what is it that you would use? Okay, this is interesting one, because when I thought about it, I did it with the so let's take this to the whiteboard and see how we can solve it. Well, we can have this, and then we have the answer a 24, 12, 8, and 6. Okay, so 24, there will be 4 times 3, 12, and 12 times 2, 24. So this product is basically coming from this. Okay, and similarly this one is coming from this and this. Okay, so basically we need, what are our constraints? We have to do it in O of n. We can't use the division. Okay, well that is percentage division looks like this. Okay, so we can't do the division. What if, like, we have prefix sum, if we have left and right product arrays, so we can say left product and right product. Now right would have the product of all the elements that are on the right side of 24. Can we do that? How would we do that? Well, if we start iterating from here and we have a variable initialized to 1, and in that variable we keep track of the product so far, right? So in this case, what would that right product would look like? We'll have 4, then we'll have 12. Okay, right. But thing is, when we are at the 12, when we are at this index, second last index, we're getting 12. What we need is 4. Of course we can divide it by 3, but we're not allowed to do that, right? So this is not something we can do. So how can we make sure that when we are here we only have the product of the previous element and not the current one? I think the trick is that the way we create with the right product array, I mean, we would iterate from the back to front, right? So here, when the value is 1, right, before we have multiplied the current number with the product so far, right, at that point we want to make use of that, we want to store that value, right? Yeah, perhaps that's what we need to do. So let's try to see how that goes, because at this time we haven't really verified that, right? That's a premise. So in the beginning, the number that we have is 1 in product so far. So we get, at this point, if somebody asks what is to the right of this, well, that's 1. And after we have stored 1, we will change it to 4. How? Because 4 will be multiplied by this, right? And so basically we need to make sure, as we're iterating, first we place the value in the right product array, and then we implement the product so far. Okay, so what would happen when we're here? We'll place the previous product, but the so far product variable will be updated afterwards, and since that is used in the subsequent iteration, and since this is the last iteration, there is no subsequent, so the last product so far value that includes this will not be used. Okay, so I think similarly we need to create a product so far uh, from the left side. Now when we have left and right both, so we are using 2n space, which is basically O of n, just so you know. And once we have that, now we are going to iterate over this array, right? Now when we are at the index I, the left product would have the product of all the elements that are on the left side, and the right product will have the all the elements on the right side. So now we're gonna create another array. This is going to be the answer. So now our space is going to be 3n, which is still O of n, but so we're gonna take a value from right and left product arrays and multiplies those with each other, and then we're gonna place that value, that answer. Yeah, I think that should do it. Okay, let's implement it. Okay, what are the constraints? We can have a negative value. That should not be a problem, I guess. Okay, so first thing first, let's create product so far 1, and then we iterate from the beginning to the end, all the way to last index, and here we are left product. Well, let's just declare the array of the size. Okay, once we have that, we have the product so far, and in the left product corresponding index, we are going to store the product so far. And currently, since there is nothing on the left side for the first iteration, so we'll store 1, and now we want to update that. So I wonder if I can do this. Yeah, seems like I can. Let's see. And we want to multiply it with, but why do you use it? Let's keep things simple and multiply it with the, so I am picking the current element and multiplying it with itself and updating. Okay. Yeah. So similarly, we'll have product so far initialized to 1 again, and now we have right product and initialized to 1. At this point it represents uh no, it was going to be an array. That's my bad. It's going to be the same size as nums because the right product is also going to be same size. So now we iterate in the reverse, so that's the last index we'll iterate from and go all the way to 0, and we are going to decrement. So, and now we'll have product so far. What is the product so far? Well, currently it is 1, and where do we wanna store it? Right product at the, so we are at index I currently, right? And at the corresponding index we want to store that, and then we wanna in basically multiply that with itself, no, not itself, multiply it with the current number, because now we want to include the current number into the solution. Okay, now we have that. Now we need an answer array. Okay, now what we need to do, we need to iterate over this one. And what do I need to do next? Okay, so where was I? So we got the loop. Now we get the product of all the items that are left and the product of all the items that are to the right. So right product, no, let's do it this way. So left product should come first and then multiply. Although it doesn't matter when we're multiplying, but it is better to keep things this way. And when you have that, you just push it over to array. Now I think this one should work. As for the time complexity of this thing, I mean, this is going to take off, and then this, I did mention the space complexity already. This is off and this is off, and so totally of 3n, but then that is, you get rid of the constants and you're left with the off n. So there's that. So other than that, what about the correctness of this algorithm? So far looks good to me. Yeah, pretty much. So we have left and right. Yep, let's try to run it. Oh, cool, worked. Yep, I mean, it's slow, but at least it is accurate.